Nearly one-third of athletes have sustained previously undiagnosed concussions, according to the AAP News. Football is the sport that has the highest rate of concussions per 10,000 exposures. When a player suffers a concussion, they are much more likely to suffer another one. And the CDC reports that having more than one concussion can cause depression, anxiety, aggression, personality changes, and an increased risk of Alzheimer's, Parkinson's, CTE, and other brain disorders. That is why my group, consisting of Rohan Duraipanian, Jack Iwinski, and Connor Boyle, has come up with the product, the Accel helmet, that will help bring more awareness to these concussions. We began the research process by looking up existing products and patents and putting them into matrices to see what works in these existing products and patents and what doesn't, and then implemented the information gathered from the matrices into our own individual sketches, which we then each compared and contrasted to see which parts worked.
After surveying and researching, we decided it'd be most effective to develop a protective helmet cover. We chose this because it would be an inexpensive product and it could help introduce parents who are skeptical about playing tackle football, and it would also be challenging for us to make a helmet that can compete with what is already on the market. We also realized that concussions being undiagnosed are also a huge problem. Less than half of U.S. high school football players sustaining a concussion reported their symptoms. So we decided to implement an accelerometer that would be used to connect to the player's or coach's phone and notify them if the player sustains an impact severe enough to cause a concussion. We also designed our padding after the Vici 01 reflex layer, and we used short lengths of silicone tubing and aligned them into columns using a polycarbonate sheet. We designed the product to be covered and stitched together with the spandex fabric, but we were unable to do that due to time.
So the first step of the build process was molding the polycarbonate sheet around the retired helmet that we got from the school athletic department. We quickly ran into issues heating it up, and in certain areas there was too much material and the plastic wasn't laying flat on the helmet, so we had to cut grooves out in certain areas. After we molded the sheet to the helmet, we cut our PVC tubing into several lengths of 1 1/4 inch, and then after that, we drilled 13 16-inch holes into the molded plastic every 1.5 inches, and then after that we inserted the PVC tubing into each hole and then fastened it with super glue. We repeated this step for the top and the side plates, and then at this point we would have covered it in spandex and secured it all together nicely so it would have strapped around to the face mask, except we ran out of time, so we super glued the pieces together, and it also helped us make the accelerometer more easily accessible for charging and use.
With the finished prototype, we then began the testing of the product. We were able to do both the control group and experimental group with accurate data. Our test was a simple drop test in which the helmet was dropped onto a concrete sidewalk with varying heights. Unfortunately, the prototype did not survive 3 different trials, and so we only got 2 drops. Our analysis of the test was that we should have used something stronger than super glue to hold all the parts together, as none of the plastic or silicone tubing broke. An ideal solution to the problem would be to drill holes into the helmet and place screws that secured the extra layers to the helmet. We then were able to test the control group and had 3 successful trials. Looking at the graphs, the drop tests without padding had more Gs overall, which proves that the padding helped. These tests further prove that the accelerometer was a great addition to the standard football helmets and can help coaches and athletes be more aware of the impacts.
So the overall design is a very early prototype, and in the real-life application, the tubing on the outside would be covered with spandex, and then that would be used to protect the tubing and the accelerometer from wear and tear. The purpose of this prototype was not to look aesthetically pleasing, but rather to show an improvement in the impact and force that is distributed on the football player and their brain. Additionally, in a real-life application, a finished version of this prototype could be sold for less than $100, and this means it offers an inexpensive extra form of protection for experienced players, and it would also be good to introduce parents who are skeptical of letting their kid play football.
In conclusion, the overall idea of the prototype with 2 added layers and an accelerometer was a great improvement. However, the execution of putting the parts of the helmet together was flawed. As stated earlier, the biggest mistake was using super glue to hold all the pieces together. With more time and more materials, we would have drilled in screws to hold the layers together better.